Hello, this is Bob Green with Frontier Precision. Hope y'all can hear me. Here today to kind of moderate and kick off a webinar series that we're going to be having over the next several months entitled Conception to Completion. So this is an introduction or overview of what we're going to be touching on. Came up with the title Conception to Completion because the term field to finish has been around for 20 years. But it's anybody in practice knows there's a lot more to it than field to finish. There is, when that initial call comes in from your client, the first meeting at your conference table, all those things, and whether it's going to be an industrial subdivision, a power line, a pipeline, a construction site, or whatever. And then there's research that's needed, clerk and recorder's office, assessor, and all that needs to happen. And part of that pre-planning is also what tool in the toolbox are you going to use. Back in my day when I was in practice, we didn't have that many. You had a total station and introductory RTK systems, and that was about it. And so we're going to kind of show where we've come and what those options are in creating final deliverables. You can move forward. Next slide. Yep. So I'm Bob Green. I'm a licensed land surveyor in Colorado. I'm a geospatial analyst at Frontier Precision. I've been here for about almost 3.5 years now. 30 years as a professional surveyor, 45 total experience. I started my career back in working for the BSE group in Boston. I've also done a lot of pro bono type things. I was a 2-term member to the monitor panel of what's now known as the Colorado State Board of Licensure for architects, engineers, and land surveyors. I'm also a past 2-term member, recent past, just several months ago now, of the Survey Engineering and Advisory Committee at New Mexico State University. That was a powerful thing because we took a failing program that was a survey engineering program, warped it into geomatics, went from about 8 students in the program, last I heard about 59. So that was pretty awesome. I'm also a published author and I do a lot of speaking, and I'm a big measurement technology advocate because I started with none. I started with a plane table, an Alidade, a transit, steel tape, and Philly rod. I also do a lot of work with the federal government, whether it be Army Corps of Engineers, Bureau of Reclamation, NASA over at White Sands Test Facility, and I got a lot of government experience as well. And I do a lot of consulting. There on the right side is a picture of me with a receiver in my hand on the job I did last November, going up the Colorado River from the Mexican border up to the Hoover Dam, running geodetic control for an environmental bathymetric type survey. And I've also been around scanning since its infancy, starting pre-Trimble having scanners with the Cyrax going up until the GX and all the way to the Trimble X7. Next slide. Also with us, who's going to be covering the mobile LIDAR applications, is Dylan Jones. He's a AGE, or an applied geospatial engineer at Frontier Precision. Has 8 years with us out of our Maple Grove office in Minnesota. He's company-wide, one of our technical scanning and survey experts, and also in mobile scanning, including the MX9 and the MX50 that we're going to be talking about here in a minute. He's also a trainer and a services consultant. He does a lot of our on-demand videos. So if you go to frontierprecision.com/on-demand, there's a lot of free videos that are available. And Dylan does a lot of those, also featured on YouTube, on our Frontier Precision YouTube channel, and also our unmanned channel for drones and ROV and those type of things as we move forward. So Dylan will be covering mobile LIDAR. Next slide, please. Then Troy Hernandez will be covering terrestrial scanning, meaning ground-based, right? Most of these units that you set up on some form of tripod. So he'll be doing terrestrial scanning. And I think this time last year, he got his bachelor's degree in survey management and specializing in route surveying from Everglades University. And he's also a AGE. He's been here slightly longer than myself, at 4.5 years. He also does a lot of our land surveying training and consulting, so partners with companies that may not have scanners or may not have some of the solutions that we have, and so on. And also our field and office terrestrial laser scanning. He's one of our top guys in that. Also is proficient in Trimble Business Center, Trimble Access, and Trimble RealWorks, which is our 3D point cloud management and modeling type software. And he's one of us, or one of the people in the company, also good with AutoCAD, Recap, and Revit. And that's extremely important with moving these products, because you can collect all the data you want, but if you can't get it into your platform of choice, it's really not worth that much. And I noticed that in the early days, you know, I'm talking around 2000-ish, 2001, when you could collect 50,000 points or 5,000 points a second, depending on which scanner, collect all this data, then put it onto a computer that would bog down, couldn't handle it. Deliverables were not really customizable, and we came over that curve. So we're now at a whole different point moving forward, and AutoCAD, Recap, and Revit are important in that procedure. Next slide. Also, doing our drone and LIDAR interface will be Nathan Stephenson. Nathan is also an AGE at Frontier Precision for around 5 years. He has a Bachelor's of Science degree in Environmental Science from the University of Wisconsin, and also a master's degree in Remote Sensing. So he's been our pretty much go-to guy moving forward with all these new products. And trust me, things change and change. You know, we found certain vendors that we like working with and kind of move forward with them. And I did that too early in my career with scanning in the early days. The difference is today is we've taken that leap where now this data is highly valuable and highly in need. He's also an FAA remote pilot. He's our company-wide LIDAR, photogrammetry, drone, and mobile scanning expert, along with Troy, who they partner up a lot on the terrestrial side. And he's a big technology trainer and consultant. Nathan and I, when we show up on jobs together, we can solve puzzles. We've done it for mines, and it's really nice, you know, to have the partnership where I don't have to know everything. I know theory and math, and then I use our technology guys to help solve the rest of the puzzle. Next, please. And our last presentation will be done by Robert Beck with Building Point America West, a new acquisition for Frontier. So I'm just starting to get to learn some of these Building Point guys that we kind of acquired a while back. And he's on the construction side. So the structural foundation, the 3D modeling, building interiors, that kind of thing. He's been a business development manager for Building Point America West, and that's his current position. 25 years of experience in this industry. He brings professionalism and passion and commitment to not only the Building Point team, but also Frontier Precision, because we're all kind of interweaved together. Even though he's on the construction side, both myself and Troy have years and years of construction experience, and I think that's valuable moving forward. And he's also a technology advocate and a true business partner here at Frontier Precision. Next. Okay, so before we get going with all this technology, technology is great, but you're only as strong as your weak link. And we can show you all this fancy data and point clouds and rotate it in 3D, put it in Google Earth, and wow, it looks great. But if it's not on a quality coordinate system that hasn't been properly surveyed, most of the data is worthless. So it's really important that we also interface with that in our final deliverable with coordinate systems. And I've been using a saying, maybe a little over a decade, that measurement is a science, not the press of a button. When I first started, we didn't have calculators. If you wanted something that added, subtracted, multiplied, and divide, that was an undertaking. So it was really time consuming, pre-technology, and we had trig tables, we had all these type of things, but we didn't have calculators unless you wanted to spend about $700-800 for a simple one. That's all changed, and people now can press a button and get an answer. But is it the right answer? We can kind of stay tuned, as through this series we'll be talking about static analysis, post-process kinematic, real-time kinematic, and Trimble Centerpoint RTX, and how they interweave and the residuals that you can see between them. You'll see the term hour of project in this presentation is data we collected. And so what I want to show is this isn't going to be canned data. We're going out, we're going to do a job, we're going to put together a final deliverable. It's going to go on a border, a title block, just like you're used to seeing on the survey side. On the environmental or DOT side, you'll see infrastructure, because we have drainage culverts that are really huge, along with a waterway that comes through there. So I think we can hit the ground on a couple of different platforms. Next slide. I kind of want to end my portion here talking about a little bit about the digital twins movement. And this is huge moving forward, because it's kind of partners with the 3D of topographic work and other things that we do with the mathematical digital twin. And it's been around for a couple of years now, but this term is really starting to hit the market. And the World Geospatial Industry Council came out with this report January 1st, and it's pretty telling on where we're at. Kind of a prime point on that Gartner scale down below on the hype cycle of looking at the innovation of this technology, the peak of inflated expectations. And I think all of you have seen that with old scanners that you couldn't produce anything. And today it's all getting more simplified, into this trough of slight disillusionment, which is going to be very brief, hitting this slope of enlightenment and moving forward. So just like RTK took off in the kind of early 2000s, the same thing is going to happen with this 3D renderings from all these various pieces of hardware and software that we're going to be talking about. So I just wanted to bring that up. As you see that term in industry publications, I'm really into it. I've been doing a lot of research to kind of see where we're at, and hopefully you'll find some of this information useful. Next. Now I'm going to turn it over to Dylan, and he is going to go through with you mobile LIDAR, mobile scanning, and his experience with that interface.
Yeah, thank you, Bob.
You're welcome.
So for those who are unfamiliar with the concept of mobile mapping, it's somewhat of a general term for data collection on the go. We mainly refer to it as a vehicle-mounted mapping system. It could be LIDAR data collection through rotating laser sensors or LIDAR sensors. It could also be imagery or street view data collection via 360-degree cameras, like you see up there in the top right-hand corner. Or it could just be both combined together into one system, but all mounted onto the top of a vehicle, like you see in the lower left-hand corner. So what this allows us to do, or what it provides us, is a way to rapidly collect as-built or as-is 3D geospatial measurements within line of sight from the road or whatever path the instrument is driven down. And most of all, we're doing this in a much safer manner compared to traditional survey methods. This technology truly shines on large projects. So here at Frontier, we do offer rental and mobile mapping technical services, consulting, that sort of thing, using our MX9 and MX50 systems. Both of these mobile scanners or mobile LIDAR systems can be easily deployed on a wide range of vehicles. As you can see in the middle image there, it mounts to the top of an SUV or a truck. And they're both very compact and lightweight, making them capable of transporting or shipping if needed. I know that we've shipped ours in between our offices, out to Seattle, up to Alaska, and everywhere in between. And so just know that they're easily transportable and can be mounted in the matter of minutes. It's truly amazing, just the hardware that these manufacturers have built. And each of these systems do have built-in INS or inertial navigation systems, along with 2 LiDAR sensors and a 360-degree camera. The MX9 does allow for additional higher resolution cameras for things like pavement monitoring or pavement imagery, as well as asset image collection. So if you want a little bit higher resolution imagery, the MX9, the one there on the left, does offer those capabilities. And both are operated from a mobile device such as a tablet or a phone or a laptop inside of the vehicle, using a wireless connection to the system. And that software that controls the system is very easy to learn and easy to operate. The biggest difference between these 2 units specifically is the LiDAR sensors. Essentially, the MX9 is going to collect more points per second, and it's going to scan longer ranges. But both are going to give you extremely dense and accurate point cloud data for you to extract your features or your line work to build those highly detailed digital twins that Bob was talking about there of the real world. So you can see here that there's numerous applications for mobile mapping. This is certainly not all of them, but rather many of the applications that our customers have had heavy interest in. I've personally worked with professionals in these 4 sectors. Some other customers, I've helped a lot of customers on very interesting projects where, for example, one thing not listed here, connected and autonomous vehicle development, where they're mapping roadways, intersections, and developing systems in which vehicles can communicate with those intersections, with other vehicles in those intersections, as well as autonomy. I've worked on other projects such as large-scale wind energy site development and waterway mapping. So it's really exciting to see all these different projects that mobile LiDAR systems can be utilized for. So when it comes to our project that we'll be presenting more in depth in the following webinar series, I have much to show you on how we utilize mobile mapping data to extract what's necessary for the end deliverable. And I'm prepared to demonstrate how we can take this point cloud data and imagery and extract things such as curb, gutter, road paint lines, power lines, utility poles, signs, buildings, trees, and the list just goes on and on. But you can see here in a couple of screenshots the colorized point cloud data and what we truly receive from that mobile LiDAR system. It's just remarkable what you can pick out of this point cloud. And for our project, we utilize the MX9 mobile mapping system. So just another screenshot of the detail and density that we'll be working with. This detail definitely allows us to use a handful of tools for extraction. Many of these tools can automate extraction procedures, which is just going to save a ton of time on your projects. A large portion of these mobile LiDAR and LiDAR projects in general is the extraction side of things, really taking that point cloud and getting what you truly need out of it. So whether that's line work, points, surfaces, contours, whatever that might be, I have in the next webinar, we're going to show you how that can be extracted with ease and efficiency. So if you've never worked with mobile LiDAR data before, you'll be blown away. I swear, this is going to be one of the coolest things that you've seen. And I think with that, it's time to pass it on over to Troy.
Thanks, Dylan. In our terrestrial laser scanning portfolio, we offer 3 different instruments that allows users to really select the appropriate instrument to meet their project needs. The 3 instruments shown starting on the top is the Trimble SX12. This is one of my favorites that I've used in the field as an end user. It's a 1-second total station with laser scanning capabilities. On the bottom left, the first time I seen this, I called it a game changer. It really made scanning less daunting. It's the Trimble X7. It's been out for a little while now. The ease of use, the speed and versatility, it's almost becoming a no-brainer for terrestrial scanning. On the bottom right is the Trimble TX8. This scanner, it offers a really dense scan point cloud, and it also offers a little bit more scanning range for those larger projects that maybe the X7 isn't suited for quite right. Next slide, please. Over the next few slides, I'll briefly touch on some of the applications that we've successfully helped customers integrate laser scanning into their workflows. Industrial surveys such as power plants or wastewater treatment plants. This is where the X7 really shines, especially when you combine it with Trimble RealWorks to start generating those 3D deliverables, creating that digital twin. On the civil infrastructure side, in this picture, you'll see the SX12. This is another project that we helped out with a customer. They were scanning a dam face, and their prisms mounted and utilizing Trimble Business Center monitoring module, as well as the point cloud to detect any kind of movement or change. There's a lot more applications, but that's definitely one for the SX12 that it's suited really well for because of the extended range. Topographic. We've had customers successfully use all 3 of the units, all 3 scanners. Depending on the size and complexity, definitely different scanners work better, but software has been the biggest change. And Dylan touched on this earlier. The feature extraction, that's really what's made laser scanning a little bit more approachable for a lot of our customers. Next slide. I think the road intersections has become pretty common nowadays for a lot of our customers. One, keeping crews out of the intersections. But again, software is really allowing us to extract the data a lot faster than what we can traditionally have done in the past manually with RTK or toll stations. The next 4 on this list, all 3 of the scanners work great for these applications. The utilities, I like this, get it scanned, the GIS. The overhead wire and transformer data capture and clearances. We've had several customers that have started doing this, especially the overhead power transmission lines. The TBC now has the extracting line features, and it's becoming really popular. Tanks and calibrations inside of Trimble RealWorks advanced tank module. I've seen over the last couple of years that become more and more applicable to a lot of our customers, just as the infrastructure is starting to age here. The cultural heritage and historic preservation. I personally have done a lot of churches and historical buildings with the TX8, and more so now in the X7 realm of things. Next slide. And finally, the DOT and railway and municipality applications. Just like Dylan had mentioned with mobile LIDAR, there are times where you need a smaller section of road, and maybe the miles of road isn't necessary for certain applications. We're having a lot more DOTs starting to get into laser scanning, and a lot of surveying company, engineering companies, and especially the end client requesting this information. The ability to limit site visits has been a huge motivating factor for a lot of our customers. Next slide. And finally, again, kind of touching back on our project, our goal was to kind of demonstrate that no matter where the data is coming from, whether it's mobile LIDAR, aerial LIDAR, or terrestrial, the deliverables are going to be extremely similar in nature. The ability to generate that final deliverable in either your CAD package or Trimble Business Center, which is what we're going to try to highlight the most, just to show that it's come a long way to help you guys efficiently collect and extract the data that you need.
All right, thank you for that, Troy. Also, just a quick note, if anybody has questions, drop them in the chat, and we are monitoring that and can answer them kind of in real time. And if we need to, we can bring up the questions at the end as well. So I'll do a quick introduction on airborne LIDAR or UAV drone-based LIDAR. So at Frontier, we do have a few different manufacturers that we represent, but kind of minusing that for a second and just talking a little bit about airborne LIDAR applications and what we can do with this technology. Go ahead, Dylan. So here are just a couple brief airborne scanning applications. These are by no means the end of them. The list is very lengthy, but these are just a few that we see daily here. So one of the biggest ones is raw land development surveys. So think of a plot of land that's out there. There's trees, there's bushes, maybe there's some streams. There's all these different features out there, and we're going to scrub that out and build a subdivision, just for example. So LIDAR gives us this ability to penetrate through that canopy, through that vegetation, and collect high quality ground data, whereas traditional methods would take a long time. Maybe photogrammetry wouldn't be well suited for areas with this type of vegetation. So we get to collect all of these different things. In this example, there's streams and fence lines. We also get heights of trees if you're into forestry applications. This can give us a bunch of different information, such as erosion and change detection as well. One of the other big things that we're seeing for airborne scanning and terrestrial scanning for that matter is power line surveys that Troy was talking about. So we're seeing companies, big power line companies, energy companies, scanning their lines for things like verification and installation of those power pole placements. Maybe you need a coordinate value on each of those placements, right? Maybe on cross members where we need measurements that are difficult and or would be time consuming to get through traditional means. Another really big thing that we're seeing with power lines is vegetation encroachment, right? Trees are going to grow near power lines, and using LIDAR, we can measure how far away things are in close proximity to these power lines, and maybe when you need to go out and trim that stuff back. Traditionally, this is done by helicopter crews, which are expensive and you can't do it as often. And they're also doing a visual assessment, right? They're just looking and they're visually seeing, hey, these trees are kind of close or they're not kind of close. With LIDAR, we can actually measure, hey, that's 10 feet. Maybe we need to trim this back in 1 to 2 years, right? We can do that with airborne LIDAR. The other big thing, and this isn't necessarily an application, is the ease and efficiency in airborne scanning nowadays. Like everyone's been mentioning, this technology has really come a long way in the past couple of years. So one thing that our customers are seeing is this ease and efficiency as compared to photogrammetry. So photogrammetry is the art of and science of taking two-dimensional pictures and creating 3D data products. That takes a long time. It also takes some pretty hefty computers to run those processes. LIDAR, since we're directly capturing that 3D data using the sensor, in order to process this data, you don't need nearly as beefy of computers. It also takes a dramatically less amount of time. Also, because this is a direct scanning technology and not indirect like cameras are, we can reduce our reliance on ground control points and still maintain that accuracy. So one of the big things that I really like to highlight is using photogrammetry. If there's elevation breaks, like let's say there's a hill, we want to put control on the top of that hill and at the bottom of the hill in order to maintain accuracy. With LIDAR, if that's sort of a trudge to get up to the top of the hill, hey, let's just put our ground control down here and we can still maintain that accuracy, which is a pretty big thing. The other big thing between LIDAR, just a second, Dylan, can you go back to that slide? Is we eliminate our reliance on sun condition. So coming from the photogrammetry world, right, we're very reliant on sun conditions. You know, is it sunny, is it cloudy? And that really affects the data when it comes to cameras. LIDAR is independent of light. It could be in total brightness, it could be in total darkness, and we're going to get that same high quality data, which is a pretty big differentiator. Go ahead. So as we've all been mentioning here, here's some data from our project. This isn't looking at the street, this is a neighborhood nearby. We also did collect that street as well, so we have overlapping data from all these different sensors. This specific one was collected using a DJI M300 for the aircraft and a yellow scan mapper for the payload. The mapper is sort of your middle of the road entry level between cost and also performance. So it's not at the upper end, but it's not at the lower end either. It's kind of right in the middle there. And when we look at this, we can see all sorts of different features. So behind this community, there's all these trees, right? And running in those trees is a little creek that we'll highlight and we'll break apart and go layers deeper into this data when we have our own Airborne LIDAR webinar series. But we can see lots of different features in here, right? We can see that creek kind of from this angle, lots of trees, buildings, but we pick up lots of little things as well, like street lights, fences, roadways, driveways, all of this very rich point cloud data that will show how to reduce into deliverables that are more consumable into AutoCAD or Civil 3D and things of that nature. Go ahead, Dylan. So this is just a quick cross section from this area that we've been talking about here. So we can see, obviously we're getting the top of trees with LIDAR, which is important. We can measure things like how tall these trees are, what their canopy width, things like that. We're also getting the understory here. So maybe these are smaller trees or brushes, that sort of thing. And then as you can see in the bottom here, we're penetrating through that vegetation and getting high quality ground data. And you'll notice a little gap in the ground data there, kind of in the middle. That's actually where the creek is. So water will absorb the radiation coming from these scanners, and we'll get a little data gap void. And that's actually where the creek is in this case. So this is something that we can do quite easily. We can cut these cross-section views. We can use it to gather information and to pull data out of these point cloud scans, and then use them in a meaningful way in Trimble Business Center and other software beyond. Go ahead, Dylan. So I want to also highlight a different sort of environmental approach to using LIDAR. So this is an interesting scan. I'll kind of describe what it is since it's a strange looking picture. Right now, what we're looking at is brown is ground, and everything else, trees in this case, are this whitish grayish color. So this is a highway here in Colorado where I'm from. This is Highway I-70, which is sort of our arterial line to go from east to west. It's also used heavily in trucking to bring goods back and forth. So one of the things that we've been working on and pushing these LIDAR payloads that can be used for environmental reasons like studying erosion and avalanches. So this is sort of a strange picture, but we're looking down a very, very steep slope, and there's a huge culvert kind of in the bottom middle there. And then that's the highway right there. So Colorado Department of Transportation uses data like this, as does Alaska Department of Transportation and other DOTs. They use this to monitor erosion and movement on these hill slopes. That could be big movement like avalanches and rock slides, but it doesn't necessarily have to be. It could be a little bit more subtle as well, and we can monitor these movements over time. And I'd like to highlight this because this slope, it's a little bit difficult to tell here, is well over 45 degrees, and it's sort of a talus rocky field. It would be horrendous to try to walk through this and gather those positions and coordinates where we need to, doing it boots on the ground. With LIDAR, it's relatively pain-free. We can allow the drone to do the work for us. We can check it using ground shots maybe that are easier to gather lower down and still gather all that necessary information that we need for environmental impact studies. Go ahead, Dylan. With that, I will introduce our next topic here, Robert Beck.
Hello, thank you. Appreciate that, Nathan. Yeah, so as Bob started off by saying, I've been around the construction industry for well over 25 years. I've been a technology advocate. And as Bob said, yeah, I started off back in the old Cyber days as well. Followed the GX scanners all the way through different iterations, and now with the X7. And just as Troy alluded to, you know, it's just been a game changer, right? Having just such a simple scanner that you can bring out, take on an airplane with you, throw in the back of your car, break out, hit one button, and start scanning. But that's also then posed the challenge with a lot of scanners over the years is, you know, as the technology's progressed, we can collect more and more data faster and faster. But what do we actually do with that data, right? What do we want to do with it? And that's what we're going to focus on throughout the series is the deliverables. Yes, how we capture it, but more importantly, what do we actually do with that data, right? And in the building point world, right, when we're focused on the construction side of things, it's getting the tools in the hands of the contractors so they can make informed decisions right then and there on the spot as fast as they can. So they're not waiting for concrete to dry or concrete's drying that they're going to have to go in and rip up, that they can make informed decisions right then and there of what's going on. So Dylan, you can flip. And some of those areas, right, are as-built documentation. As we all know, construction documents are prepared based upon, you know, hopefully as-built conditions, but more importantly, when we start getting into a building, even the Denver airport here locally, right, that's 25 years old, a lot of the construction documents are not accurate. So if you've been through the airport, you'll see targets all over the place, and I know, you know, my good friend Troy here was scanning a lot of late nights there at the Denver airport, capturing true as-built conditions, right? And so that's what we want to do is we have the construction documents, what was built, and so as we're building from that, we're building correctly the first time. So that comes into the renovations and TI type of work. And then coordinating the new designs versus the existing. So you'll see some of the pictures here to the upper right, that's going out of a boiler room, an MEP room, where we had, you know, lines going in this very small tunnel, which you can't tell is tripods actually shrunk down there. We had to duck down to get in. But, you know, being able to capture a lot of information in areas where we didn't have information before. And then check for clashes prior to construction, right? Make sure that if we're tying into existing conditions, we're tying in the right place and we don't have a bulkhead in the way, we don't have existing piping or concrete barriers in the way. Progress monitoring, right? For owners, that's a, you know, big factor is owners want to know what's happening out there. You know, what's installed, when was it installed, and so we can get the pay quantities going. So doing a progress monitoring. Field QA QC, right? So how's it being built? Is it being built to spec? Are there problems or issues? Let's document it along the way for the submittal process. And then of course the final documentation, right, for the turnovers for the owners. So they have the records of what was built exactly as things get covered up. So prime example is we did a hospital and they wanted to capture all the oxygen lines that were buried in the walls as they're coming down. So now we know with millimeter accuracy where those were captured or where those were placed. Next. Couple examples here. So in the field of scan, you know, the BIM world, we're actually now able to bring in that 3D model into the tablet, scan against it in the field, and without having to go back into the office, because once again, time is money in the construction world, of course everybody is, it's being able to look for those clashes and those problems, you know, right then and there in the field. So in the upper left, you can see, if I remember right, this was an area up in Billings where we had the model, brought it in, started doing some scanning against it and checking for conflicts. In the lower right, you can see we brought in actually a PDF file into the tablet, was able to scan directly against it in the field. So now we see the overlays, and you can see where some of the stub ups were placed against where the design was supposed to be. So being able to scan directly in the field, not have to worry about scanning, exporting the data, transferring the data, re-importing that back into the office, and then running reports, we can scan directly in the field and right then and there have the information at our fingertips to be able to make some informed decisions. Next. Another great example is floor analysis. Being able to scan a concrete pour and right then and there in the field, be able to run some FF and FL numbers so we can figure out what the floor flatness or floor levelness is. Once again, directly in the field, takes several minutes to do this. Next. And inspections. Concrete's poured, things are in place. Let me run an inspection report out in the field from the model versus the scan data, and then show me a heat map, a color-coded heat map with whatever tolerances I choose, right? I can go down to an 1/8 of an inch, 1/4 inch, 1/2 an inch, as I did here, and then be able to see the scan data against the model and check for variation. So the upper left image here is kind of a zoomed out area. And the lower right, you'll see that you can see where the scan data is, and the bright green is within that tolerance. As we start to get to the darker green and blues, we're starting to get to 1/2 an inch to 1 1/4 inch out of tolerance. And of course, anything in the red is going to be a little 2 inches out. So you can see in this image that we've got some of the walls where the wall was supposed to be. It's actually to the left about 2 inches to where it should be. Next. I'm going to turn this back over to Bob. I think he's going to do a little recap for us here.
Yeah, so what we're going to be doing is we couldn't have 1 hour and go through all the details of all this technology. So we've decided to break it down into various sessions. So they're going to be separated by a month. Dylan will hit up mobile mapping and LIDAR with a lot more examples. Also, the differences between the hardware, differences between software that we can use, and then hopefully getting this into a product such as Trimble Business Center to help create a final deliverable. Then Troy will take over the terrestrial scanning portion at the end of August and move that agenda forward. Keep in mind, there was a picture on one of his slides of the X7 underneath a culvert. Why? Because terrestrial couldn't get it because it's driving down the road or over the bridge. Aerial LIDAR couldn't get it because it's 350, 400 feet up in the air. So we needed to interface with the terrestrial LIDAR. In our final deliverable that we'll be talking about, all of this high-tech data, although you don't need every sensor, I mean, we could have done this with 2, but it's all going to come together. And so we're going to finalize that on the geospatial survey side with aerial and drone LIDAR from Nathan. And that'll be the last week of September. And this is where we're going to take the top 2, mobile and mapping and terrestrial, giving to the project manager what I call quasi deliverables, like some line work done, whatever. Then we're going to merge that all into one data set. And we're also going to do some QC so we can see how physical observations underneath canopy work with the actual data that we're collecting and come up with some spreadsheets and analysis for you to look at. And I just came off of a job, not just, but that job I did in November. And from the Mexican border up to the dam on the Colorado River. And all that control that we set wasn't really for the end game of survey, but was for a bathymetric and environmental and erosion type deliverable that interface with LIDAR and green LIDAR, because as Nathan showed you in that one slide where the creek was, there was no data. Green LIDAR's job is to penetrate that water and get down there to see sedimentation, erosion, and all that kind of good stuff. Then we're going to end our presentation with Robert going more into detail with the build team and construction deliverables, which is becoming huge. I remember back in the late 70s, I helped with the State Street building in downtown Boston, and we were hired because the building wasn't going up straight. So we had to do beam camber elevations, and we had a Zeiss Ni2 level with a micrometer and an Invar leveling rod and all this, what was fancy stuff at the time. But we're walking on beams, 40 stories up in the air, where today a lot of this could be done from below or with less risk of keeping yourself out of harm's way. So that'll be our last presentation. And then Robert will hit on a lot more of these various construction workflows, both interior and exterior, and then deliverables, quality control analysis and reports, and all that kind of good stuff that we're going to be working through here over these next 4 sessions that we have here, ending up in October of 2022. So next slide. Okay, we've covered a lot of information, and this kind of puts glue to everything that we talked about, from Nathan's vehicle up there to the upper right with a MX unit on it, and he is on our project. That was the day he collected the data. Going over to the left to Troy's world, and then the imagery in the map screen of what you can see in Trimble Access out in the field. Over to the X7 with the perspective software, where everything is done live in the field. So one of the problems I always had with scanning was interfacing with spheres and different targets and whatever. And you never knew until you got back to the office whether you were right or whether you were wrong. Here you can tell if you've got enough data right while you're out in the field. And then down to the bottom right, interfacing with drone data, whether that's coming from some form of DJI copter or fixed wing or vertical takeoff VTOL unit, and then also with Robert's data there. So any questions, we'd be more than happy to address them, and it may point us in the direction for our future webinars.
So yeah, just looking at the questions here, we do have one. It is, what viewer program are you using to look at the LIDAR cross section? And I think that was the image that Nathan had on one of his slides where it was showing the trees, brush, and ground. So Nathan, maybe you can speak to that.
Sure thing. So that specific cross section was derived in Trimble Business Center, which is the software we've kind of been mentioning, and we'll go into deeper, a little bit deeper when all of us have our different presentations. But TBC, for me, it's really powerful, and one of its strong suits is being able to combine all of this data, not necessarily data from the different scanners, obviously you can do that, but we can combine our scan data with our survey data, with our CAD data, all in one platform, which is a really powerful thing. So specifically, that was in Trimble Business Center.
And for a lot of you who aren't aware, Trimble Business Center, if you do not have a TBC license, you can actually install TBC on your computer, and you can import data as a viewer. You can do a lot of things in regards to just viewing, if that's all you're really after at this moment. But obviously the power expands as you equip yourself with a license. So did want to bring that up. And we'll see if any other questions trickle in here. We can also hang out here for the next couple minutes if anything does come in, but I think at this moment, that's all we have.
And I think the final thing that I'll say is that what I'm hoping is the difference between this presentation and others that you may have gone to is we're not really going for the wow factor. We're going for a deliverable, something you can put out the door. And you know, the day is coming in our industry where the difference between geospatial and geodetic, there's going to be lines drawn there. There's going to be different solutions. It's all going to happen interfacing with this 3D data. This digital twins movement is real, and it's going to keep moving forward along with the client's need. When you show a client 3D true data, they never want to go back to black lines on a white piece of paper. They just don't want that no more. So this whole thing is moving forward, and my part of getting this conception to completion is going to be helping you understand for the type of survey that you're doing, the type of accuracy and precision that you need on your control, that's pretty much going to depict success or failure. And that's where I'm going to pipe in on each one of these sessions moving forward. And Troy is also a great resource for us on that as well. So we have a full team at Frontier Precision, both on the drone side. We also do have photogrammetry solutions, but I'm seeing photogrammetry kind of fall off a little bit. Not in mining, because in mining they don't have any canopy to penetrate, so it works fine there. But I think everybody's been burnt by, you know, contouring the top of hay or something like that, and that happened to me back, well, not to myself, but a company I did work for back around 2001, where, hey, Bob, the contours are 3 feet off. No, you contoured the top of the hay, and that was truly the case. So I was able to make an extra 19K back in the day, doing it all field because they didn't trust anything that came back from the photogrammetry folks. So anyways, if there's any more questions, let us know. If not, we'll probably wrap it up here a couple minutes early.
There were just a couple that trickled in. One of them was more of an enhancement request. So we'll take that one offline. Just has to do with maybe some metadata when it comes to scanning. And then the other one is maybe something we can actually help answer together. The statement is, my deliverables for scanning is still mostly slower than traditional topo. So I feel like I need to figure this out. I guess I can take it here just to start. I do feel that that scanning in general is not designed to fully take over all the traditional methods. Okay, there's definitely projects where scanning is right and traditional methods might not be as applicable. So, for example, when I brought up mobile LIDAR, long linear projects, doing that, let's say 10 miles with a mobile LIDAR system versus with traditional means, I would put money up against a mobile LIDAR system any day of the week to be able to perform that type of survey faster with mobile LIDAR versus traditional methods. So there's definitely projects where LIDAR or scanning does become beneficial to increase or decrease the risk of safety and to just be more efficient in the data collection side of things. Does anyone have anything else to maybe mention about that?
Well, I could pipe in. I think the point is valid when it comes to like certain types of terrestrial scanning, where especially with, you know, units like we have today with the R12i, you can put it on a wheel, you can locate curb and gutter on the interior of, say, an Alta survey and stuff like that. And so I think there is something to it, but there is perpetuation as well. So when you go into your office and you see a fire hydrant in there and you see no coordinate next to the fire hydrant, guess what? You don't have to make a return trip to the field. when your client calls you up after you've done an Alta survey a month later and says, guess what? We now need building heights. You're not back out in the field. You've got the perpetuation. So if nothing else, that's where that SX12 comes in real handy, because you can do traditional work with it. And then before you pick up, spend 7 to 8 minutes, do a quick little scan, and you've got that perpetuation plus photo documentation to back up your survey and cut your liability. So I think there is something to that. But when you're on a big linear corridor, or I just this morning was taking ground truth shots on an aerial flight that we flew in about 45 minutes of about 25 acres or so. So I'm going out there as a surveyor to qualify that data. There's no way with the terrain out there that I could have got that done. That would have been 4 or 5 days worth of work up and down those hills. And also we got the penetration through canopy, and that was exactly what I did this morning for a couple hours between about 8 and 10:30 before it got too darn hot. But anyways, I do understand that question, and there is some validity to it, but I think the perpetuation is worth the investment.
I will also mention that a couple of years ago, our colleague Jay Haskamp did a webinar on just LIDAR productivity in general, comparing mobile LIDAR to aerial LIDAR to photogrammetry and traditional methods. He kind of just went through all four on a just a case study basis. And if that is something that is that's something you want to check out, we could definitely make a post about that to get that into people's hands. So that was an interesting case study that he did that might be worth a view.
And also don't forget about our on-demand site. We have a lot of freebies on there. So you could watch an hour webinar on a particular topic, and it's pro bono. We have others that are very inexpensively priced. And so our on-demand is gaining popularity along with our YouTube channels. And Dylan's really been actively involved in that and producing up-to-date webinars on what's going on with our technology.
Hey, Bob, that's great stuff. I did want to just chime in here and just kind of just reiterate. I think it was brought up a couple times, but the safety aspect, right? So it's being able to collect that data when you're not in harm's way. So the intersection scanning from a buildings world, right? Being able to go into buildings and collect remote without scaffolding, having to put up scaffolding, having to get a cherry picker in. And being able to collect as much data as you can from a safe position. And we're starting to see the emergence of technologies like Spot the Dog, right? So being able to deploy Spot the Dog, the Boston Dynamics robot with the payload of a scanner on its back, and deploy it to run missions and then come back and dock at night or during the day, just whenever. So yeah, just want to drive home the safety aspect of it as well.
I'd also like to bring up, isn't this webinar going to be available? It's being recorded, but how do people get access to the recording? Do you know?
Yeah, I think what we'll do, and we've done this in the past, is we've uploaded the webinar to our YouTube channel. So I did mention this case study. This is the title of that case study if you're interested. And we will post this webinar from today up on our YouTube page as well. So be on the lookout for that. I think that's all the time we have for today. So Bob, if you want to wrap it up and say your goodbyes.
Yeah, so stay in tune because we're going to be having one of these once a month. Again, they'll be recorded if you can't make it, but please sign up first. So the end of next month will be Dylan's turn to go more into a deep dive with mobile LIDAR. But one nice thing is, even if you're not interested in mobile LIDAR at this time, a point cloud is a point cloud. And working with point cloud data doesn't really matter that much where the sensor was. It's all how you get it into software. So it's going to be real eye-opening to see that we're going to take all this various sensor data, put it into one software, and create one deliverable. So thank you for attending.
Thanks, Bob.